Welcome to another video of thematic lectures. Well, this question is question number 17. So here, this is a question related with a pulley system. A pulley system is used to lift a 5 kilonewton load through a height of 1.5 meter. The system consists of one fixed pulley and the other pulley can move. The pulley are connected by nylon rope. Here, that 5 Newton load is shown here. This is the moving pulley and this is the fixed pulley. The nylon rope will stretch when it is used in this way. The weight of the pulley and the rope can be ignored and you may assume there is no friction in the pulleys. The properties of the nylon rope are the Young's modulus is 2.7 gigapascal. The overall length of the rope before loading is 6 meter. The cross-sectional area is 3 times 10 to the power of minus 4 meter square. So the first question we need to address is the greater the length of a rope, smaller the stiffness of the rope. Explain why. So this is a theoretical question. So we know the idea. That means if the length of the rope is high, or if the length of the rope is greater, so what happens? Longer will be the deflection, the cumulative effect of the reflection, deflection, or the elongation will be more. And we know the equation for the basic equation for stiffness. F is equal to K times delta X, correct? Therefore, if you are making stiffness the subject, F by delta X. So for the constant force, if the length is more, the overall elongation will be more. So if a denominator quantity keep on increasing means obviously the numerator quantity, that stiffness quantity, will decrease. That is very obvious. So that is the answer for this question. So how will you frame this question? The greater the length of the rope, the greater the extension for a given force. F is equal to K delta X. So K is equal to F by delta X. So if delta X increases, K decreases. So how will you answer this? So if delta X increases, K, the stiffness, decreases. So that is the idea for this lesson. Hope you got it. So move to the B part of this question. Show that the stiffness of the nylon rope is about 1.4 times 10 to the power of 4 Newton per meter. Okay, so here the load is being given or load is being applied. That is 5 kilonewton. As a result, what happens? This will extend. So the force that is responsible for the extension is F, because F has some direct relationship with the 5 kilonewton load. So we can keep that in our mind. So we need to find the stiffness, right? So basic equation for Young's modulus Y. What is the equation for Young's modulus? It is stress sigma over strain. What is stress? It is force per unit area. So what is strain? It is delta X by original length. that is capital L. If it is the original length is del L, then we can say the strain is delta x over L. So here you can plug these values. So what happens? F over A divided by delta x over L. That is Young's modulus. And if you are rearranging this, what happens? This L will be going to the numerator. F times L divided by A times delta x is the value of the Young's modulus. And suppose if you are cross multiplying and if you are making F the subject, F is equal to Young's modulus times area times delta x divided by L. Because you can bring this L to the denominator. So if you are comparing with the basic equation, F is equal to K times delta x. If these two equations are comparable, this value is the stiffness, correct? Therefore, what is the equation for the stiffness? Young's modulus times area over length. So you just substitute. What is the Young's modulus in this question? It is 2.7 gigapascal. Giga means 10 to the power of 9. So 2.7 multiplied by 10 to the power of 9. And what is the area? 3 times 10 to the power of minus 4. And the original length is 6. So if you are substituting this, you will get 1.35 times 10 to the power of 5 Newton per meter. So it is about 1.4 into 10 to the power of 5 Newton per meter. So that is the answer for this particular question. Clear? So can I move to next question? The second part of this question, question number 17. So in second part, they are saying the pulley system lifts 5 kilonewton weight at a steady rate. Determine the extension of the rope while the lift is taking place. So while the lift is taking place, we need to find the extension that is happening to this spring. So here you can see this is the force F. So obviously there will be a tension. So the same tension will be distributed here. The same tension will be distributed here because it is a single cable or a single rope. It's the same material. So whatever be the extension, the same extension is actually happening each and everywhere. So the tension will be same. So if you are drawing the free body diagram of this beautiful pulley, because the pulley is actually frictionless as well as weightless, and even the weight of the rope is also negligible, and this is the tension T, and this is also the T, and the weight is what? 500, no, 5 kilonewton means it is 5,000 Newton. So it is going in the steady rate means the net acceleration is equal to 0. So net force acting on the system is equal to 0. So if you are writing the free body diagram and if you are writing the equilibrium equation, 2T minus 500, 5,000 is equal to 0, or 2T is 5,000, or T is equal to 5,000 upon 2. So what is the value of T? T is 2,500. And the same T is actually the value of F. So now we got the value of F. So what is the force value? It is 2,500 Newton. And we are in a position to find the extension. Correct? So what is the equation? F is equal to K times delta X. So we got the value of K, 1.35 times 10 to the power of 5 Newton per meter. And the value of F also we know, that is 2,500 is K times delta X. K you can substitute here. So if you want to find the extension, 2,500 upon K value is 1.35 times 10 to the power of 5. And if you are substituting this, we will get 1.85 times 10 to the power of minus 2 meters. So that is the answer. So extension of this is 1.85 times 10 to the power of minus 2 meters. Hope you got the idea about this. Now, the next question is calculate the work done in the stretching of the rope. So if you are drawing a graph of extension versus F, we will get a straight line because the equation of F is K times delta X. And if you want to find the work, the area under the force delta X graph is, area under that is actually the work done. So it is in the shape of a right angle triangle. The equation for work done is half times F times delta X, correct? So that is half times the force is 2500 and the delta X happened was 7.85 times 10 to the power of minus 2. And if you are evaluating this, you will get 23.132. So the work done is 23.132. Clear? So that is the idea for this question. So this is the elastic potential energy stored inside the beautiful rope. Yes. Now the last part of this question, the C part of this question, what is that? Assess whether the stretching of the rope has a significant effect on the efficiency of the pulling system. That means we have two different types of work that is happening. One is the external work and one is the internal work that is happened inside the rope. So the equation for the external work, W, we can say that by the basic funda, we can say that that is force multiplied by displacement is the work. So what is the force? It is obviously 5,000 Newton, and that is lifted 1.5 meter high. So if you are multiplying, the answer is 7,500 Joule. So 7,500 Joule. So this is the external work, or this is the work done by pulley system. And what is the work done internally, or elastic potential energy? So that is 23.132. So we can say that 23.13 Joule is very, very less compared to 7,500 Joule. So therefore, what is our comparison? Because what is our question? Assess whether the stretching of the rope has a significant effect on the efficiency of the pulley system. Since 23.13 Joule is very, very less than 7,500 Joule, it has no significant effect. There is no significant effect on efficiency of the pulley system. Efficiency of the system. So that is the answer for this C. Clear? Hope you got the idea. So this is the idea about all these three questions in question number 7, right? So we did A, we did B, and we did C also. So that's the idea about this lesson. So if you have any doubt, any clarifications, or any theoretical explanations you require, please be free to comment below in this comment box below this video. Definitely you will get a reply. Thank you very much.